Hi, my name is Ulises Lopez.
My name is Anthony Oliver.
My name is Eli Cowart.
My name is Jorge Garcia.
And this is our project.
Alright, this is the experimental setup that we have. So we have the water container where we are going to be filling up the water. And we have the thermometer to see how cold the water is. So we can find the viscosity and everything else we need. We have the tube right here, which is 3/8 inner diameter. And right here is where we're going to be injecting the dye to be able to see the flow of the water. And right here we have the measuring device to calculate the flow rate and then find the velocity. And we have the background to make it more clear and visible.
So these are our calculations for each Reynolds number for the different flows. I want to go over our knowns and also some of our constants. So for laminar flow, the Reynolds number will always be below 2,100. Transitional will be between 2,100 and 4,000. And turbulent will be greater than 4,000. So the diameter of our tube stayed the same and constant throughout the whole experiment, along with the temperature of the water, the density, and the viscosity. So we use the same process to calculate the Reynolds number for laminar, transitional, and turbulent flows. We first measured the amount of time that it would take to fill up 1 liter with water. From there, we took that volume and divided it by the time, giving us our flow rate. And then we manipulated the flow rate equation to give us our velocity, which we then used to plug into the Reynolds equation and give us our value for that flow. So our first laminar test we did with blue dye. It took 53.71 seconds to fill up 1 liter. From there, we were able to calculate our flow rate being 1.86 x 10 to the negative 5. From our manipulated flow rate equation, we were able to calculate our velocity to be 0.25 meters per second. And using all of those values to plug into our Reynolds number, we got 2,086. And as you can see in the video, the flow is very smooth and not chaotic, clearly showing that it is laminar. And as you can see, the same can be said for our red dye test as well, which yielded us a Reynolds number of 1,919. And with both of our Reynolds number being below 2,100, we can clearly see that those flows were laminar. So moving on to the transitional flow, the first thing that you can notice from the video is that the flow is definitely more chaotic. So during this test, it took 39.6 seconds for us to fill the liter, which yielded us a flow rate of 2.53 x 10 to the negative 5. And from our manipulated flow rate equation, we calculated that the velocity was 0.355 meters per second, which plugged into our Reynolds equation gave us 2,963. So from there, we can see that that is between 2,100 and 4,000, which lines up perfectly. So for turbulent, you will notice that the flow is more chaotic and that it also fills the liter up faster. So for our first test with the blue dye, it took 9.91 seconds to fill the liter. And from there, we calculated our flow rate to be 1.01 x 10 to the negative 4. And with our manipulated flow rate equation, we calculated our velocity to be 1.41 meters per second, giving us a Reynolds number of 11,769, which is well over the 4,000 mark, showing that the flow is turbulent. So for our turbulent test number 2 with the red dye, it took 13.14 seconds to fill the liter. From there, we calculated our flow rate to be 7.61 x 10 to the negative 5. And then from the manipulated flow rate equation, we got our velocity to be 1.069 meters per second. And from our Reynolds number equation, we got a value of 8,922, which is well over the 4,000 mark, showing that it is a turbulent flow.
And thanks for watching.